All right, guys, welcome back. This is part 3 of lesson 6.5. Now we're going to look at specifically how you can solve these exponential equation problems where you want to try to find the exponent or at least estimate the exponent solved by graphing. So here's how this works. A town, we're going to look at a couple of problem examples. A town has 55,783 residents. The population is increasing at a rate of 5% per year. The town council is offering a prize for the best prediction of how long it will take for the population to reach 75,000. Make a prediction. So it's just a prediction. So what we need to do is talk about where we're at. So we are starting with 55,783 people. So in our equation, P of t, which is the same thing as f of x or y, that's where this is going to go. That's the starting amount of people. That's our base. How many people? And then we're going to end. We need to end at 75,000 people. And then the growth rate equals 5% or 0.05. And so we need to add that to what there would normally be, which is 100%, which is 1. So our function then is going to be P of t equals 55,783 times 1.05. That's our population growth. Okay, if we want to, this is a growth of 5%. So basically what we're multiplying by is 105%. Okay, that's what 1.05 it recognizes as. This is 105%. And then we're going to take it to the t power. And so we want to know what t is equal to. So what will t be, or what will P of t be? Like, how many years is this going to take? So we can graph this on the calculator to find when y would be equal to 75,000. All right, so let's talk about the graphing calculator and how it works to do this. Okay, so let me hit focus real quick, see if I can focus that in a little bit better. All right, good. So over here you see this y button, y equals. We're going to click on that, and then you can see we have a list of y values. This is where we can input a function. So I'm going to input a function here for this, which is going to be the function that we have already written. So I'm going to keep things in parentheses, just kind of keep things separate. So I'm going to take 55,783, put that in parentheses, and then I'm going to multiply it by 1.05. Put that in parentheses, and then I'm going to take it to the t power, or in this case, x. So I'm going to use this caret button. This caret button, that's how you take something to a power. So caret, and then I'm going to click on the alpha button, alpha, and down here, we've got x. X is the only variable that your calculator will recognize for an unknown. So don't put any other letters here. Don't put A or C or F or H or M or anything else. X is the only one. Okay, so now that's set, and you can see that this is highlighted. Y1 equals this equation. This calculator is now going to graph that. Now all we have to do is push graph, and it'll graph it. However, it might not graph it in a way that will allow us to see it. We have to set up the perimeters of the graph. So I'm going to go to Window, and I want to set up minimums and maximums. Okay? So we have to think, what is x in this case? Well, x is the amount of time, right? The number of years. So I'm going to put as a minimum, x is equal to 0, because I think that'd be pretty good. And then for a maximum, I can put 10, I could put 20. It just depends, like, how many years do you think it's going to go Let's put 20 just to be safe because we don't know how many years it's going to take to reach 75,000. Hopefully it'll be less than 20 years. If not, we can always come back and redo this. And then I've got the X scale. I'm going to leave that at 1. That's usually the best scale to do in here, unless your graph gets too big or too small. And then for Y minimum, well, let's look at what we've got here. We're starting at 55,783. So I'm going to make my minimum 55,000. Okay? And then the maximum, well, we want to reach 75,000. Now, don't put this in as your maximum, because if you do, it'll be all the way over in the corner of the graph and you won't be able to see it. But put something that's, a little further out. So I'm going to put in, I'm going to put in 90,000. That seems pretty good. And then the Y scale and the X resolution, I'm going to leave those at 1. So now I can hit graph. And you can see it's graphing a nice line, okay? And if over here, if you see that little motion, that means it's still graphing. That little motion has now stopped. So now what I can do is I want to find the place. So I'm going to hit trace. And now I can use the side-to-side button. And I can go from X value to X value, and it'll tell me what Y is equal to. Well, I want to know what X is when Y is equal to about 75,000. Right now I'm at 80,000, so I'm going to keep going down, down, and down, and down. And there I'm at 75,377, and we can see that it's 6.17. I'm going to go down again to 74, it's about 5.9. So if I'm estimating, I know that this is going to be about 6 years. Again, it's just an estimation. Okay? I can do the same thing again for this next problem. There are 300 wolves in the state park. The population is increasing at a rate of 15% per year. Make a prediction for how long it's going to take the population to reach 500. So, again, we start with 300 wolves. It's increasing at a rate of 1.15. So there's 100%, and then there's the extra 15% that's going up over T years. So again, in my calculator, I'm going to go to Y. I'm actually going to clear this one out, and I'm going to put in our new function. 300 times 1.15 to the alphabet X power. Okay? I'm going to go to my window, and I want to make sure that this is, yep, it's been chosen because it's highlighted. Go to Window. I'm going to keep my X minimum and maximum at 0 and 20, but now we're dealing with a very different population. Notice this started at 300, so I'm going to start the Y minimum. I'm going to call it 200. I'm going to call the maximum. We want to go up to 500, so let's just go up to 1,000. And now I can hit graph. And it's going to give me a nice graph. Wait till the little bars stop rolling. Okay, it's done. Now I can hit trace. And I can go through. I'm going to go until Y is about 500. Okay, so there, X is equal to 3.8. Down here, X is equal to 3.6. So it would appear, depends on how you want to round it. We could say it's, somewhere between 3.6 to 3.8 years. But if we're just rounding off to the nearest year, we would say that it's about 4 years. Okay, so it's going to take about 4 years to get to a population of 500. So that's how we can estimate it. If we zoom in on the graph a little more, we can get a more exact number, but all we want to do is just estimate the number of years.